Let's look at a couple of simple examples of circular motion. First, let's take the International Space Station. The International Space Station orbits the Earth at roughly an altitude of 400 kilometers. Let's say that it orbits the Earth once every 90 minutes, which is just about accurate. We want to find what's the radius of rotation of the International Space Station, what's its period, frequency, velocity, centripetal acceleration, and centripetal force. All right, let's start off with the radius. First of all, the information that's given us is that it has an altitude of 400 kilometers. The problem is that this altitude is only the distance from the surface of the Earth. If we want the true radius, it has to be from the center of rotation to where the International Space Station is, and that would be to the center of the Earth. So as a result, we find that our radius, is going to be the radius of the Earth plus whatever altitude the International Space Station has. The radius of the Earth is around 6,380 kilometers. A lot of that type of information is actually inside the front cover of your textbook. A lot of information on the radius of the Earth, the mass of the Earth, the distance of the Earth to the moon, distance of the Earth to the sun, lots of different information like that. Okay, so the total radius then would be the radius of the Earth, 6,380 kilometers, plus the altitude, 400 kilometers, which gives me a total of 6,780 kilometers, or 6.78 times 10 to the 6th meters. Okay, there it is. That's the radius. That's the first thing done. The second thing on our list is the period. Well, what is the period? It's the amount of time it takes for one orbit. Well, the problem gave that to us. It orbits the Earth once every 90 minutes. We can go a little bit further than that as well. We can say what is the period in seconds. Just convert from minutes to seconds, multiply by 60, and we find that the period of the Earth is 5,400 seconds. 90 minutes also works for the period, but we're going to need it in seconds, so I wanted to do that. What's the frequency of the Earth? Well, frequency is just 1 divided by the period, so that's 1 divided by 5,400 seconds, which means you go through 0.00185 revolutions per second. Okay, so that's the period and the frequency. Let's shift gears and talk about velocity. Remember, the velocity of any object in circular motion is just going to be the circumference of that circular motion divided by the period. So 2 pi r divided by t. So we just found the radius and the period earlier. So if we plug those in and calculate it, we get 7,888.9 meters per second. That would be how the actual speed of the International Space Station as it goes around the Earth. That means it's almost going 8 kilometers in 1 second. That's a pretty impressive speed. Okay, there's velocity. Let's move on to centripetal acceleration. So here's the information that we found, the radius, the period, and the velocity from the previous slide. For the centripetal force, we're going to need the mass, and so I looked that information up and I gave that to you. The mass of the International Space Station is 419,709 kilograms. Okay, centripetal acceleration is defined as the velocity squared divided by r. That information is given on the left, so we just plug that in. So 7,888.9 meters per second, that needs to be squared, divided by the radius, which is 6.78 times 10 to the 6th meters. Plug that in, and you find that your centripetal acceleration is 9.179 meters per second squared. Okay, let's talk about centripetal acceleration, or centripetal force. Remember that centripetal force is just mass times acceleration, and acceleration is just v squared over r. So if we had not calculated the centripetal acceleration, we could use the form on the right, the mv squared over r. But since we calculated centripetal acceleration already, let's just use that, mass times acceleration. So centripetal force is mass times acceleration. Find that product. We find that the centripetal force is 3,852,509 newtons. Okay, let's do a second example here. Let's say you have a car on a circular track. It accelerates from rest to 60 meters per second in 5 seconds. If the track has a radius of 100 meters, what is the total acceleration when it reaches 60 meters per second? So we want the total acceleration. Remember that this is not uniform circular motion, which means we have both tangential and centripetal accelerations. So we're going to need to find both. Let's start off with tangential acceleration. Remember that tangential acceleration is defined as change in velocity over change in time. Talking about speed. The change in velocity, we went from 0 to 60, and the time was 5 seconds. So we get 60 minus 0 over 5, which comes out to 12 meters per second squared. That's our tangential acceleration. Okay, let's do centripetal. Centripetal acceleration we find as v squared over r. V is 60 meters per second. Notice that in the question, I specifically asked what is total acceleration when it reaches 60 meters per second. Although the tangential acceleration was 12 meters per second squared for the entire time it was speeding up, the centripetal acceleration was changing as the speed changed. Okay, so if I continue, I may continue speeding up at 12 meters per second squared, but if I do that, then I'll have a different velocity, therefore my centripetal acceleration will change. That's an important point to note. I just wanted to point that out here. Okay, since we're calculating it when we reach 60 meters per second, that's my velocity. Divide that, square that, and then divide it by the radius of the track, which is 100 meters. So you get 60 squared divided by 100, gives you a centripetal acceleration of 36 meters per second. Excuse me, meters per second squared. Okay, so we have tangential and radial accelerations. Now we use Pythagorean theorem to find the total acceleration. So just take the square root of both sides. Tangential acceleration is 12, radial acceleration is 36. Square both of those, add them together. Then take a square root, you get a total acceleration of 37.95 meters per second squared.